three things today. We're going to find the average value of a function. We're going to use the MVT for integrals to find a C value. And we're going to use the second fundamental theorem of calculus to evaluate derivatives of integrals.
Awesome.
So those are the three things we're looking at. So, average value, we should know how to do average value already. What do you think average value is?
F of B minus F of
Say it again.
A. F of B minus F of A.
No.
Change in function above over time.
Change in the function above over the change in time, or if it's just general, it's going to be the change in the x value or the change in the interval. Okay. Now, what has to be, Logan said f of b minus f of a over b minus a. What has to be in the prompt in order to use f of b minus f of a? Of change. If you don't have of change, you need the change in the function above over the change in the interval. So in this case, how am I going to represent the change in the function above? Integrate it, right? So I'm going to integrate it from -1 to 2 of 4x cubed minus 3x squared dx. So that's the change in the function above. What else do I need?
Change in the interval.
Change in the interval with the b.
Interval.
Interval with the b. So that would be divided by 2 minus the -1. So it's what we've been using anytime we find average of something, as long as of change is not there. If of change is there, then I need f of b minus f of a. Okay? Alright, so on the bottom, that gives me 3, so I'm just going to make a 1/3 out front. That way it doesn't get too messy. Now I'm ready to integrate, so what do I get when I integrate 4x cubed?
X to the 4.
X to the 4th, and when I integrate 3x squared, I get x cubed. We're going from -1 to 2. Plug 2 in, that gives me 16 minus 8. I plug in -1, that gives me 1 minus a -1.
You can leave the 1/3 out.
Leave the 1/3 out there. Needs to stay there. So 16 minus 8 is 8, and then that's going to be 8 minus 2, so that's going to end up giving me 6. So then I have 6 divided by 3, which is 2. And what is 2?
Average value.
That is the average value. Now, does anybody have any thoughts on what it represents besides the average value?
Area under
A tangent line. Secant line.
No.
the
Stop.
antiderivative.
Let's graph it and see if that will help us.
So point on the graph and explain that function
It is sine line.
or the interval.
Alright, so the original function is 4x cubed minus 3x squared. So 4x cubed minus 3x squared. Okay, and let's deal with our window. Our window is from where to where? -1 to 2. And anytime we change our window settings, what else do we do?
Zoom fit.
Zoom fit, good. Window and zoom fit. So there, that gives me it. So there's my function between -1 and 2. Okay, and we found the average value to be 2. So let's figure out what that is. What does 2 represent if it's the average value?
The average y value.
Outstanding, Brock. That is exactly what it is.
So the average
He
value.
said 2.
Average y value.
He said 2 represents the average y value, and he is dead on the money.
Sweet.
So how'd you come up with that, Brock?
Dead on money. You don't get one if you're dead on
On the Bakersfield.
Shot in the dark.
It's a lot below until the very end. It shoots up.
All right, so
I think
2
that
2 is going to be right in there. So I have all these y values over here on the left, below 2, and I have all these y values over here on the right, above 2. And if I take the average of all of those y values, that would give me a y value of 2. That's exactly what it is, Brock. Very nice. Outstanding.
Rock, just backwards, that's right.
Now, you can also do something else with that average value. Okay, and that is make a rectangle with it. So if I make a rectangle with the y value of 2, and I go this direction to where that limit is, and I go this direction all the way over here, that produces a rectangle with some area in it. What do you think is true about the area of that rectangle that is produced?
It's 2.
It's 2 by whatever.
It's not 2. The height of it is 2. What would the actual area of it be?
6.
It would be 6, because I have to take the height times how wide it is. So the area of that is actually 6. There's something else in there that gives me an area of 6.
Under the x-axis?
And that is the area under the curve of the function. So if I take this area right in here, and this area over here, the area of that is what?
6.
Should also be 6. Okay. So it does, the average value does 2 things. The main thing we want to do is what Brock said, is we want to realize that that is giving us the average y value of all the y values between on that interval. Okay? But it also gives me the height of a rectangle that does what? It also gives me the height of a rectangle that produces the same area as the area under the curve. So if I go back here, if I go back to this, what is the area under the curve?
6.
It is 6. And isn't that what we said it was on that rectangle? Yes. So it does 2 things. The average value does 2 things. What Brock said, it's the average y value, but it is also the height of a rectangle that produces the same area as the area under the curve of the function. That is what it does. That's the average value. Okay, and we need to get that in our heads before we move on to the second piece. All right. Before we go to the second piece, now, MVT, we've heard that acronym before. We've heard MVT before, mean value theorem. But before, what were we using when we were doing the mean value theorem? A-rock equals I-rock. That is correct. But what does that involve? This one says the mean value theorem for integrals. A-rock equals I-rock is the mean value theorem for derivatives. Now, who can tell me, who can set and 2 things that are equal to each other that A-rock equals I-rock? How do I represent A-rock?
Change.
Or average.
Average rate of change. So how do we represent average rate of change?
F of B minus F
F of B minus F of A over B minus A. And how do we represent I-rock? We do it with the instant rate of change, which is, it ended up being F prime of C. Okay? Now, what did we use this to find?
Where are A-rock and I-rock equal?
Okay? And be more specific than where. What is it we're finding?
Slope.
Finding a point of C value.
Right, what does that C value represent? You guys are all around it and not here saying the word I want to hear.
Where they intersect.
The average y value.
The C is the X value. It's the X value that produces the instantaneous rate of change that is equal to the average rate of change. Okay? So it's where the instantaneous rate of change equals the average rate of change. Okay? So, say it again. So that leads us into the mean value theorem for integrals. And it's very, very similar to this. How can I represent that with an integral?
Big S.
But it would be the big S. What's inside of it?
B on
B
top.
and
A to B.
Or B to
B on top.
It would be, yeah, A to B. I agree with that. What else? F of what?
B.
C.
It's actually
F.
f prime of x, isn't it?
Where'd the X come from?
Why is that prime?
Why is it f prime?
I don't know.
Because you're doing this function
Because
above.
what does an integral give me?
Function above.
The change in the function above. So if this is the function above, then what I integrate has to be the function below. Okay? Divided by b minus a. Okay? So what's on the other side? It's still f prime of c. The mean value theorem for integrals and the mean value theorem for derivatives is actually the same thing.
So
It's
what's
just
this?
starting at a different spot. Okay? Now I want you to notice something here. Notice what is inside my integral and what is over here on the left side. They are the same function. What is inside my integral and what is over here is the same function.
So that's why on here it's just f of c versus f of x.
So, if you go to what we have on your note sheet, notice that the inside and the outside are the same function. Okay, and this produces the same thing as the mean value theorem for integrals does. Okay, now with what we just did on our first example, what does this represent here?
The average value.
Average value. What did Brock say the average value was?
Average Y value.
So this right here represents the average y value. Okay, so what does that mean? That side over there is going to produce.
Average, or that's average.
It's not the average y value, it's just a y value. Okay, so we're finding the place where the y value equals the average y value, and we're interested in finding the c. And what does the c represent?
The X value.
The x value,
Where they are equal.
the x value where this right here happens. The x value that gives me the y value that equals the average y value.
Why are the primes?
Because we're just doing it in general. Okay, we use the primes to show you that we're dealing with the same thing, but when you see the MVT, then the primes aren't going to be there. That's why I showed you that what was inside of the integral is the same function as what's over here. So it doesn't matter if I put f or f prime or f double prime here, I need to understand that it's going to be the same function over there. So if we're going to say it in general, we're not going to use any f primes.
And you use this to find C?
We're going to use this to find c. And c is what?
The X value.
The x value that produces the y value that is the average y value. Just like on the mean value theorem for derivatives, we found the x value that did what?
Equal
That gave me the
average.
instantaneous rate of change that equaled the
Average.
average rate of change. So in this case, we're finding the x value that gives me the y value that equals the average y value. That's what we're wanting to do with the MVT. Okay? And Alex, it's okay if you're not following me. Okay? You'll understand once we do that. So,
No, just please.
we're going to do 3 examples that deal with this. So our job is to use the mean value theorem to find the value of c that must exist. Okay? So what do I want to do first if I have f of x equals 9 over x cubed and my interval is 1 to 3? What's the first thing I need to find?
Set it equal to
F
the
of C.
thing.
Set it equal to the thing.
Integral.
What was on the right side of the MVT?
The
A
integral
rod.
f
What?
x
A rod.
dx.
Back up here.
Oh, that was
Back up here. What is on the right
average
side?
Y value.
Average
I need to find the average y value. That's the first thing I need to do is find my average y value.
So that's the first problem.
That is the first problem. That's why we did the average value first, because I need to know that. So, average value, I'm going to do 1 to 3 of 9 over x cubed dx. Alright, then what? What I want to do is, and I'm forgetting the 3 minus 1 on the bottom as well, correct? So what can I pull out in front of the integral before I integrate?
1/2.
I can pull out a 1/2, but what else could I pull out that's better than 1/2?
1/3.
6.
Just kidding.
9 halves.
I can pull out 9 halves. Because I've got a coefficient of 9 up top, so I can pull that 9 out and I can pull the 2 out. So I have a 9 halves out front. So really the only thing I'm integrating is what? 1 over x cubed, which is the same thing as x to the negative 3. So if I integrate x to the negative 3, I get x to the negative 2 over negative 2 from 1 to 3. So I have some more coefficients that I can pull out. So now I can do a negative 9 over 4 out front. And when I plug in, I only have to plug into 1 over x squared. Okay? Yeah, I multiply the 2's together and put the negative out there. So if I plug in 3, I get 1/9. If I plug in 1, I get 1. What is 1/9 minus 1?
Negative 8
Negative
ninths.
8.
Negative 8/9. And when I multiply those two together, what do I get?
Positive.
I get a positive 2. Now, what does that 2 represent?
The
Average value.
That is the average value, which is the average y value. And what am I interested in finding?
The X value that gives you that.
The x value that gives me that y value. So what am I going to do now to get the x value that gives me that y value?
Plug that,
Plug for x f of x.
plug that in for f of x.
Plug that in for f of x. Very good, Brock. So I have 2 equals 9 over x cubed. What do I want to do to solve that?
I thought you were going to plug it
Multiply
into
by
MVT.
Plug it into the MVT.
What do you do with MVT?
That's how you
You mean up here?
That's how you
You don't have to use it?
Yeah, I do. We just found this part. We just found this part. Okay, and it's actually kind of
Oh, okay.
I can't stop you. Every time I take a breath.
it would be like this. Okay, I just found this part which was 2, and now I'm trying to find the x value. So f, here's f. So I set f equal to this. If you want to get technical, then c goes right there. Because if I'm doing f of c, that means I'm plugging c in for f, so that gives me the 9 over c cubed. So then that gives me 9 over 2 equals c cubed. So I get c equals the cube root of 9 over 2. Now, what did I find in that c? Outstanding. That is the x value that produces the y value that is equal to the average y value. So let's verify that on our graph. All right, add a graph. It was 9 divided by x cubed. Is that correct? Yes. 9 divided by x cubed. We need to do our window. What was my window from where to where? 1 to 3. Okay, we always want to go back and do zoom fit. All right. So now what can I do to verify what I found is correct? Say it again. I can find 2, or well, I can plug something in that will give me the 2. That's what I want to do. So we're going to go menu. We're going to do the trace. We're going to do the graph trace. We're going to press enter. We're going to press escape. Now I want to go in here and change this x value to what? No. The cube root. I want to change it to the cube root of 9 divided by 2. And when I do that and I press enter, what y value should match up with it? 2 should match up with it. So I press enter, it gives me the y value of 2. Okay? So I have all these y values over here. I have all these y values over there. If I took all those y values together, added them up, and divided by the width, what would that give me? That would give me 2. Okay? What else can I do with that 2?
Make a rectangle.
I can make a rectangle with it. So if I make a rectangle here and here, and I find that area, it should be equal to what? The area of the curve. So what is this area? If I'm going from 1 to 3 and my height is 2.
2 times.
4. So that means the area of the curve should be equal to 4. Okay, let's try another one.
X's and C's.
Alright, next one. G of x equals x minus 2 square root of x from 0 to 4. I want to find the c value that the MVT for integrals guarantees. So what do I do first?
On the average.
Find the average value. So I'm going from 0 to 4 of x minus 2 square root of x dx, and don't forget to divide by 4 minus 0. So that means I can take a 1/4 out front. What do I get when I integrate x? X squared over 2. Now I want to think of the square root of x as what?
X to 1/2.
X to the 1/2. So x to the 1/2 turns into x to the 3 halves, which means I need to multiply by 2/3. So I end up with a 4/3. We're going from 0 to 4. All right, so plug in 4. If I plug in 4, that's 16 divided by 2 is 8. When I plug in 4 here, 4 to the 3 halves, what do I have to do to 4 if I'm racing it to the 3 halves? Square rooted and cube it. So the square root of 4 is 2. 2 cubed is 8. And 8 times 4 gives me 32 over 3. And then what happens when I plug in 0? I get 0. So what is 8 minus 32 over 3?
Negative 8 over 3.
Negative 8 over 3. And 1/4 times negative 8 over 3. Negative 2/3. What did we find at negative 2/3? The average y value. The average y value.
So we'll have two answers on these. One.
You can have 2 answers. Okay, and we'll get, I think this one does have 2 answers on it. Alright, now that I found my average y value, what do I want to do?
So equal to G of x.
Set it equal to g of x. So I'm going to do negative 2/3 is equal to, let's go ahead and put the c in there, c minus 2 square root of c. Alright, now I can't solve this one as easy as I solved the last one. So what are my options using the calculator to be able to solve this for c?
Type it in.
Here's what we want to do. We want to move the 2/3 over.
Good answer, good answer. So makes sense.
And then I want to graph c minus 2 square root of c plus 2/3. And when I graph that, what am I going to be looking for?
Where it equals 2/3.
Not where it equals 2/3, where it equals 0. Because now, once I've moved it over, I'm interested in where it equals 0. Okay? If I did the original, then yes, I'm interested in where it equals negative 2/3.
Can you do that?
You can do that, but it's a little bit more difficult. I recommend moving it over and looking for where it equals 0.
Question. Will this be a calculator problem on the test?
Yes. You have to do some of these with the calculator and some without. So let's graph that. So control dot, I need a new graph. So it was x minus 2 square root of x and plus 2/3. And let's change the window. We're going from where to where on the window? 0 to 4. I press enter. Zoom fit. I want to do zoom fit. There it is. So as you see, there are 2 places. So we want to go menu, analyze graph. We want a 0. There's one right there. Menu, analyze graph, 0. Right there. Now, what do I do in this case when it only gave me 2 decimals? And I need 3.
Plus.
Hover over it and do a plus. So I get 0.179 and 2.488. what's going on with those two values?
Where it equals average, whatever.
That kicks out the y value that is the same as the average y value. So now we need to graph it without the 2/3 on it.
So the average y value is 0.
No. That's not the function we want to be looking at because we changed it up. We want to go back to the original without the 2/3. So we want the x minus 2 square root of x. Press enter, menu, window, 0 to 4. And menu, window zoom fit. Okay, we'll do the trace, draft trace. We press enter and escape. And now we want to plug in those decimals. So when I plug in 0.179 and press enter, what should the y value be? Negative 2/3. What does negative 2/3 look like as a decimal? Because that's what it's going to give it to me as. Negative 0.666. So I press enter. It gives me what I want. So then I change it to the other one. 2.488. And what should that produce? The same thing. Which gives me that. So it also produces the same thing. So we found the x values. That produces the y value that matches the average y value. And what else can I do with this point right here? Make a what? I make a rectangle. If I make a rectangle there and a rectangle this direction, the area of that rectangle is the same as what? The area underneath the curve. Those are the two things we found. All right, let's do one more average value. So this time our function is cosine of x. Our interval is from negative pi over 3 to pi over 3.
Yeah, thanks.
Alright, so what do we need to find first?
Average y value.
Average y value, and how do I do that?
Integrate.
Integrate and divide. So integrate from negative pi over 3 to pi over 3 of cosine of x dx, and divide by pi over 3 minus negative pi over 3.
Which one's the negative? What? On the S?
Bottom. Okay, what's pi over 3 minus a negative pi over 3? 2 pi over 3. When I pull that out and flip it, what's it turn into? 3 over 2 pi. Okay, when I integrate cosine, what do I get? I get sine. And we're going from negative pi over 3 to pi over 3. So I plug in, we get sine of pi over 3 minus sine of negative pi over 3. What angle are we dealing with pi over 3? 60. What's sine of 60?
Square root of 3.
So square root of 3 over 2. Okay, what about this one on the right where it's a negative pi over 3?
Negative.
Makes it negative, so it's going to end up being positive. So what's the square root of 3 plus, the square root of 3 over 2 plus the square root of 3 over 2?
Just square root.
Just the square root of 3. So I end up with 3 square root of 3 over 2 pi. What does 3 square root of 3 over 2 pi represent?
Yeah, average y value.
The average y value. Now what?
Set it equal to cosine x.
Set it equal to cosine of c. So 3 square root of 3 over 2 pi equals cosine of c. And again, that's something I can't do, so I'm going to have to use my calculator. So what I'll do is I'll use my calculator. Subtract it over. Alright, so we had cosine and minus control divide 3 3 square root of 3 over 2 pi. Press enter. Menu. What are my window settings?
Negative pi over 3.
Negative pi divided by 3. Press enter, menu, window, and fit. Okay, so we see there are 2 of them. So I'm going to go menu, analyze graph, 0 here and here. What do you think it's going to be on the other side?
Positive version.
Positive, yeah. Analyze graph 0 here and here. So what do I have in negative 0.597 and positive 0.597?
Value that produces the y value that's the same as the average y value.
Outstanding. So that is the x value that produces
Rob
the
got
y
it
value.
wrong.
That is
That's
the
why
same
I'm
value
voting.
I didn't
as
get it
the
wrong.
average y value.
No.
All right, so that's average. That's average value. That's mean value theorem for integrals. And real quickly, the second fundamental theorem for calculus is extremely easy, and it's one of my favorite things.
Oh.
So is it
Okay.
really easy or is it one of your favorite things?
Both.
I don't believe you. I don't believe you.
It's easy for you too. Now look at this. What's going on right here? What is this asking me to do?
Or the derivative of the integral.
The derivative of the integral. Now think about that.
Cancels each other out.
They should cancel each other out.
So it's
It's just f of t.
FT.
So this right here, it's not f of t. You have to plug in this variable that's up top. So it would actually be f of x.
That's really all we have to do.
That's it.
Wow.
Yeah, so just wait until we get to your homework and start to do this.
I
Now,
think that's all it is.
you may hear 2 other things you might see. Okay, notice this time, instead of x up here, it's x cubed. Okay, you start the same way, so I'm going to plug in x cubed, so it would be f of x cubed. However, if you're plugging in something that is not just x, you have to also multiply by the derivative of what you're plugging in. So I also have to multiply by 3x squared. So this one would be equal to 3x squared f of x.
But if you plug in constant,
You don't worry about the constant, you only look at the variable.
I thought-
Why is it-
so it doesn't have to be on top to plug it in.
You
No,
don't
that is
plug in-
correct.
What if you don't leave the cube?
Oh, yes, you're right. Sorry.
So even if you're
So let's look at these. Let's look at these 3 examples.
You said there's 2 other things you might see.
Well, the other one's in there. You'll see it here in just a second. So derivative of the integral from 10 to x of t times t squared plus 1. What is that equal to?
x plus
X times
x squared plus 1.
x squared plus 1.
That's it.
That's it.
Sweet.
Nailed it.
Now, what about the second one? The derivative of the integral from x to 5 of 3 plus cosine of t dt.
3 plus cosine of x.
2 plus cosine of
3 plus cosine of x. Negative. Oh.
Why does it make sense to put a negative?
Because you have to flip it.
Yeah, because I want the x on the top. So if I flip it, what do we have to do?
You have to change the sign.
We got to change the sign. So if I flip it to move the x on the top, that means I've got to have a negative, and then I plug in.
What if you have x on top and bottom?
Not gonna
You're
happen.
never plugging in
What if
a
there's no
number.
X?
You're always plugging in the variable.
If they're gonna have, if they're wanting you to use the second fundamental theorem of calculus, there's gonna be a variable in there. Okay, then on this last one, what's this last one gonna equal?
Nothing.
Square root sine.
Square root of sine
Oh.
times
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 Time.
cos.
times cosine. Here it is.
Is that the derivative? Yes.
Derivative of sine is cosine. So you plug it in and
Wouldn't
multiply by this.
It wouldn't be negative since it's cosine.
It is not, because what's the derivative of sine?
cosine.
Cosine. You gotta think about what
I'm
you're doing.
going about.
You're thinking about the integral instead of the derivative. Okay, now this will show up on the AP test, but when it shows up on the AP test, okay, now notice all 3 of these, I could actually integrate this and then come back and take the derivative. So if I integrated this and then took the derivative, this is what I'm going to end up with. But if it shows up on the AP test, what is in here, you're not going to be able to integrate. So they're going to force you to know this rule. Okay? Because they're going to put something in here that you can't integrate. So you've got to know, all I have to do is plug in and multiply by the derivative. Okay? So that's the second fundamental theorem of calculus. Okay? Pretty easy though, isn't it? Okay? So when I'm taking the derivative of an integral, I just need to plug in and multiply by the derivative.